Hi folks, take a look at this shape. We covered it in last week's Fusion Friday, but it tapers in all directions, which would mean it's a pretty difficult part to work hold. Easy to machine, difficult to hold. Window machining. Thanks to Amish Solanki from SS CAD Cam who gave me this tip. Coincidentally, I saw a bunch of window machined parts at PMTS. Perhaps that's selective perception, but let's take this chunk of aluminum and let's machine it into this really cool shape. It happens to be the golden ratio, which from a design standpoint I think is really cool, but the takeaway here is a really, I think, smart way to work hold. We're going to keep it simple by just flipping it with sort of 3-axis machining, but if you have a 4th or 5th axis, even more possibilities here. Welcome to another Wednesday Widget. Let's find our Z0. So we're using a origin point at the bottom of our stock, and since the stock is resting on parallels, let's just find the top edge of the parallel with our Heimer, and then in PathPilot we'll set that to Z0. We're using a bore on this part that we machined and actually reamed. That way it's just a little bit more reliable and easier when we flip the part, which is a really important thing, so that when we flip it, we maintain the correct origin. You could use the outside of the stock, especially if there's a machined edge, but here I like the bore. Find the right side and hit divide by 2. That puts us right in the center of that bore. Same thing in Y. Go to X0, now find the front edge of the Y, the back edge, divide by 2, we're done. Let's make some chips. So the machining strategy is really important here. What we're doing is we're starting with a 3D adaptive. We're using a square-shouldered tool to do the majority of this work. Our typical Tool 31, it's a Lakeshore Carbide 3-flute aluminum cutting end mill. And as you can see, what we're going to do is we're going to stair-step this down just to hog out the material. It actually looks really cool. I didn't even intend for it to. One of the settings to pay attention to in the adaptive, last tab linking, no engagement feed rate, make sure that's set to your machine's fastest travel rate. After we finish the adaptive, we're going to move to a scallop, but we're doing what I call a rough scallop. So we're switching now to a bull nose end mill. This tool is a Lakeshore that happens to have a 45-degree radius, and that does a lot of things. It helps give us better surface finishes. It also reduces the weakest point of the tool, and it lets our cam give us a better tool path to generate some higher speed machining moves. So what we're doing here, though, is we're taking a wider step over, 150 thou at 30 inches a minute, just to kind of knock off those stairs and get to a point where then, with our finished scallop, we can go with a smaller step over and hopefully get a better surface finish. So we flip the part over, folks. Notice that it's important to flip it in the Y here, not the X. And now I'm using a torque wrench. Well, here's why. I don't want to put too much pressure on this, and that's one reason why we sacrificed a little bit of stock here on the left-hand side to give us some extra strength as we remove material here, or the window doesn't collapse on us. Exact same recipe where we do the 2D adaptive and then we do a sort of roughing scallop, a finishing scallop, then we get into the adaptive. So we're doing a lot of material removal here, as you can see. I was thinking about it afterward. You could do this with a shear hog. You could actually drill a lot of it out. The cycle time here was pretty long, about 25 minutes, although I have been really impressed with the 770. We ran this at 10,000 RPMs, 45 inches a minute, with a 50 thou step over and 0.3 inch depth of cut. But nevertheless, there are probably faster ways to do it. I like to sort of set it and forget it. And it was fun. It's actually, the time lapse turned out great. It's much more exciting to watch the time lapse than it was to let it go by in real time. The key here is the tabbing with the window machining. So we're maintaining 4 points, top, right, bottom, and then this whole left-hand side. So that way, as we adaptive out, we've still got 4 points of contact holding onto it. And this works really well. It's not to say I wasn't sure how far we could push it and how thin and little and shallow we could make those tabs, but it's pretty cool. So now we need to cut those tabs down. We aren't leaving any stock radially, but we are leaving just a little bit on the floor so that as it walks around here, we still have those 4 points. We've just removed most of that material. In fact, sort of ironically, we were at the PMTS trade show and they had a number of high-end 5-axis parts that were done with this, like making implants, making teeth for people or molds. Really cool. So what's crazy is you've actually got some strength left. I can bump it up and down, but now we need to cut those tabs away. Here I do stay 5 thou off the side. That way when I come across, we're actually left with a tiny 5 thou blip on the bottom, which we can then go hit off on the Scotch-Brite wheel. So it turned out really well. I probably could have left less material here. I'm glad that I used the torque wrench. There's sort of a bragging rights thing about how thin can you leave this little tab here and still have it hold on. I've seen some pretty thin parts. I was pretty conservative on this one, but it still has a little vibration ring to it. You can kind of hear it. And the surface finish is spectacular. I wasn't always a big fan of the Tormach 770, and I actually, especially since how much aluminum we cut, I do really like it. Hope you guys enjoyed that. Hope you learned something. Kind of opened my mind to different ways to think about, again, work holding and how to kind of control your toolpath, the area, CAD, CAM. Awesome stuff, folks. Take care. See you soon.